I was looking at my phone this morning,
Yeah.
just kind of mindlessly scrolling through the usual chaos of notifications. And I had this really weird realization.
What's that?
We've completely stopped calling it sci-fi.
Oh, right. Yeah, absolutely.
I mean, for decades, you think about it, the idea of a machine that could actually think or talk back to you or like actually do things for you, that was strictly movie magic.
Right. It was C-3PO or the Terminator.
Exactly. But now,
Yeah.
it's literally just Tuesday. It's the digital partner sitting in our pocket right now.
It really is. It's become the wallpaper of our lives, and almost overnight, too.
Yeah.
But, here is the problem with that familiarity. We get really complacent about what these things actually are.
We stop asking how they work.
Exactly. We
Yeah.
start using words like AI, machine learning, generative, and agentic completely interchangeably. Like they're all just the same magic spell.
Guilty as charged. I mean, I think a lot of us just kind of nod along when someone at a meeting mentions large language models while secretly hoping nobody asks us to explain how the thing actually works.
Yeah, right. And that is exactly why this deep dive is so necessary.
Right.
Because these are not just marketing buzzwords, they represent fundamentally distinct architectures.
Yes.
The shift we are seeing right now, it isn't just about computers getting faster like they did in the 90s. It is a structural change in how we process reality.
Which brings us to our source material for today. We are unpacking a really comprehensive guide titled simply, What is Artificial Intelligence?
It's a great primer.
It is. And our mission today is pretty specific. We are going to pop the hood.
I love that.
We aren't just going to look at the shiny exterior of these apps. We're getting into the engine. We want to help you understand how a machine actually learned, distinguish the actual math from the media hype, and tackle this new concept that's arguably way bigger than ChatGPT.
Agentic AI.
Exactly, agentic AI.
Let's start at the absolute baseline then. The source material defines AI in a way that is a bit broader than what most people might expect.
Right, because people just hear AI and think robots.
Exactly, and it's not just hardware. It's a field of computer science. The definition the source gives is that AI is a system designed to mimic human capabilities.
Mimic being the operative word.
Right, specifically things like reasoning, problem solving, creativity, and decision making.
It's about creating systems that can perceive an environment and then take actions that maximize their chance of achieving a specific goal.
Precisely.
But to do that, you need a brain. You need a way to process all that information that isn't just acting like a fancy calculator.
Right.
And that is where we get to the foundation of everything we're talking about today, machine learning.
Machine learning, or ML. This is the engine.
Okay, so let's distinguish this from standard coding. Because for a really long time, for decades, coding just meant writing a very long list of instructions.
Yes. Think of traditional coding like a recipe.
Okay.
You are the chef, and you sit down and write exact instructions. Step 1, boil water. Step 2, add pasta. Step 3, wait 10 minutes.
Very linear.
Totally linear. The computer just follows the rule book. It does exactly what you tell it to do, nothing more and nothing less.
Right.
If you forget to write a rule for what happens when the pot boils over,
The computer just freezes.
exactly, it crashes. It has zero intuition.
It can't improvise at all. It's super brittle.
Precisely. Now machine learning flips that entire script upside down.
How so?
Instead of giving the computer the rules, you give it the data and the answers, and you ask the computer to figure out the rules.
Oh, wow.
So you're basically telling the machine, here are 1,000 completed chess games. You figure out how the knight moves.
Okay, so it's inductive reasoning.
Yeah.
You're giving it the raw experience and asking it to derive the underlying logic.
Spot on. And the source breaks this down into 3 distinct flavors of learning, which I think is really helpful for you to visualize how this actually works under the hood.
Yeah, let's go through them.
The first one is supervised learning.
Okay, this one honestly felt the most like school to me. It's basically like using flashcards, right?
That is the perfect analogy. You have a data set that is fully labeled. So you show the model a picture of a house, and you explicitly tell it this is a house.
Right.
You show it a car and say, this is a car. You are holding its hand through the data. You are supervising the entire process.
So the goal is that eventually I can show it a brand new, totally unlabeled photo, and it can predict the label based on those patterns it learned from the flashcards.
Exactly. It's pattern matching based on a teacher's answer key.
But what happens when you just don't have an answer key? Like you don't have those labels? That brings us to the second type, right? unsupervised learning.
Right. And unsupervised learning is where the system has to get a bit more detective-like.
Okay.
In this scenario, you dump a massive amount of raw data into the system, let's say millions of transactions from a grocery store chain.
But you don't tell it what to look for.
Not at all. You just say, find the structure.
So it's looking for clusters of information.
Exactly. It scans all that data, and it might notice, hey, there is a really strong statistical correlation here. People who buy diapers on Thursdays also tend to buy beer.
Oh, yes, the classic retail example.
It's famous for a reason. It finds these hidden patterns and anomalies that a human analyst might literally never notice because we just aren't looking for them.
It basically organizes the chaos without ever being told what the categories even are.
Exactly.
Which brings us to the third one. And the source highlights this as being super crucial for things like robotics and gaming, reinforcement learning.
Yes.
This one sounds a lot less like going to school and a lot more like, well, dog training.
It is actually a very scientifically accurate way to think about it. Reinforcement learning is based entirely on a reward system.
Okay.
You don't tell the AI how to win the video game or how to walk across the room. You just give it a score.
So you just set up the basic parameters of what is good and what is bad.
Right. If the robot takes a step and it manages to stay upright, the score goes up. It gets a digital treat. If it falls over, the score goes down. So it is just trial and error on an absolutely massive scale.
So it might try a million different ways to move its robotic leg, most of them failing miserably, until it randomly finds the one specific movement that gets the treat.
Exactly. It just learns to maximize the reward function over time. This is literally how we teach robots to navigate dynamic environments.
Wow.
We don't sit down and program the physics of every single joint. We just punish the system when it falls and reward it when it succeeds.
Okay, so that is the brain of AI. That's machine learning.
Right.
But we need to go deeper here, literally,
Yes.
because the source material shifts gears to deep learning. And I feel like this is where the terminology really starts to get muddy for people.
It definitely does.
Is deep learning just kind of extra strength machine learning?
It is a subset of machine learning, but it is a very specific and incredibly powerful subset.
Okay.
If machine learning is the broad concept of learning from data, deep learning is this highly specialized architecture that is actually modeled after the human brain itself.
Right.
We are talking about artificial neural networks.
Neural networks. We hear that term constantly in the news. But what does that actually look like in the code? Because obviously it's not actual biological neurons.
No, definitely not biological, but it mimics their structure. Imagine a huge web of interconnected nodes. These are your digital neurons.
Okay.
In a traditional, simpler machine learning model, you might have an input layer, maybe one or two hidden layers of processing in the middle, and then an output.
So it's fairly shallow.
Right, it's shallow, and it can handle basic spreadsheets and numbers really nicely.
And deep learning is deep.
Very deep. It has hundreds, sometimes thousands of these hidden layers stacked on top of each other.
Wow.
And the structural difference is absolutely critical because of the type of data it allows us to handle.
Right. This is the deep factor the source really emphasizes. Unstructured data.
Exactly. Traditional computers love structured data. Rows, columns, Excel sheets, they eat that up.
But the real world is incredibly messy.
Yes. Think about a photograph, a voice recording, a messy handwritten note, even just the tone of my voice right now.
All unstructured.
It's chaos to a traditional computer.
Right, because a normal computer looks at a digital photo of a cat and it just sees a giant grid of pixels. It doesn't know the concept of a cat.
Exactly. It just sees numeric values for red, green, and blue. But a deep neural network processes that chaotic data in a hierarchy.
Okay, break that down.
So the very first layer of neurons might just be tasked with recognizing edges, just finding where dark pixels meet light pixels.
It doesn't even know what the edge belongs to, just that a line exists.
Right. Then layer 2 takes those edges and combines them to recognize basic shapes. Circles, triangles, curves.
Okay.
Then layer 3 combines the shapes to start recognizing actual features. Eyes, ears, whiskers.
Layer 4 might recognize textures like fur.
Exactly. It builds the understanding from the bottom up.
And by the time you get through 100 of these layers, the system can say with 99% confidence that is a tabby cat sitting on a wooden fence.
That ability to find patterns in total noise is why we suddenly have self-driving cars and voice assistants that can actually understand us when we mumble.
So the breakthrough wasn't just better math. It was adding enough layers to the network to actually handle the complexity of the real world.
That is the big takeaway. Deep learning is the sole reason we are seeing this huge explosion in capabilities like real-time speech recognition and advanced medical diagnostics.
It allows the machine to finally see and hear rather than just read numbers on a spreadsheet.
Precisely.
Which segues perfectly into the next major evolution in the text. We've gone from analyzing things like asking, is this a cat, to actually making
It's
things.
a generative revolution.
This is the shift that completely captured the public's imagination around 2022.
It really did, because until very recently, AI was mostly analytical. It was a classifier.
Right.
It looked at data, and it put that data into a box. Generative AI, or Gen AI, flips the switch from analysis to creation.
We're talking about your Chat GPTs, Midjourney, all these tools that create completely original content from scratch.
Right. And they are powered by what the source calls foundation models.
Specifically, large language models, or LLMs.
Yes. These are massive deep learning networks that have been trained on essentially the entire internet. Terabytes and terabytes of text, books, articles, code.
But the way they work, and I think this blows people's minds when they first learn it, it's not that the AI actually knows the answer to your question.
Not at all. The source describes it purely as prediction.
It's just highly advanced autocomplete.
Basically, yes. It's probabilistic. They are simply predicting the next most logical word in a sequence.
Right.
If I say the cat sat on the caramone, the model calculates that Matt is statistically the most likely next word based on billions of examples.
But because they do this prediction with such massive amounts of data and so much context, it starts to feel indistinguishable from actual reasoning.
It does. It mimics reasoning beautifully.
It's so interesting because the use cases, the source lists for generative AI are already so widespread. You've got marketers generating ad copy, programmers using it to write Python code, artists creating full digital designs in 10 seconds.
It's like having an entire creative staff on speed dial.
It really is.
Yeah.
But, and here's where the source material gets super provocative for me, generative AI is already kind of becoming old news.
It is. We are rapidly moving into the next phase, which is agentic AI.
Agentic AI. This was the part of the reading that really made me sit up and pay attention. Because generative is very cool. It writes a poem for me.
Yeah.
But agentic implies agency. It implies it is actually out there doing something.
That is the exact key differentiator. Generative AI is passive.
Right.
It waits for a prompt, you ask, it answers. Agentic AI is autonomous. It doesn't just talk to you, it takes action in the real world.
The example in the source notes was about travel booking, right?
Yes. Think about the difference here. A generative AI, like a standard chatbot today, might give you a really nice list of boutique hotels in Tokyo and maybe a link to a cheap flight.
Which is helpful information. But the burden of action is still totally on you.
Right.
I still have to go click those links, punch in my credit card numbers, check my work calendar, pick the window seat.
Correct. And agentic AI works fundamentally differently.
How so?
You give it a high-level goal. You just say, book me a trip to Tokyo for next week under $2,000.
Okay.
The agent doesn't just give you a list to read. It actively goes to the airline website via an API. It checks your Google Calendar to ensure you're actually free those dates.
Wow.
It books the flight. It reserves the hotel. It pays with your stored credentials. And then it just sends you the final confirmation email.
It actually executes the entire workflow.
Exactly.
That is a massive leap forward. We are going from, hey, write this nice email for me, to, hey, go run this entire project for me while I sleep.
The source calls this a move toward full machine autonomy.
Full machine autonomy.
Yes. It's not just about content creation anymore. It is about total enterprise automation.
Right.
Imagine global logistics systems that don't just alert a human manager about a shipping delay. They automatically reroute the cargo ship, update the customer's delivery window, and file the insurance claim without a human lifting a single finger.
It sounds incredibly efficient.
It is.
But honestly, it also sounds a little terrifying. Like we are just handing over the keys to the kingdom.
Well, before we get to the terrifying parts, and we will get to the challenges, let's acknowledge the real-world benefits here.
Fair enough. The source does lay out some pretty sweeping positive impacts across a bunch of different industries.
The benefits are undeniable, particularly in fields where human data processing just hits a biological limit.
Like healthcare?
Exactly. Take healthcare. The source discusses how AI is currently being used for surgical precision and early disease prediction.
Yeah, I read about these systems that can predict patient deterioration in a hospital, like 6 hours before a doctor or a nurse would ever notice the physical signs.
Right, because it's seeing the pattern in the raw vitals. It sees the microscopic shift in heart rate variability or blood oxygen levels that a human eye simply cannot detect.
Or look at drug discovery.
Oh, that's a huge one.
We are simulating millions of chemical combinations digitally to find new medicines in a matter of weeks. That's a process that used to literally take decades of physical lab work.
Decades and billions of dollars. And in finance, it's revolutionizing fraud detection.
Right.
It spots the tiny anomaly in a massive global transaction log instantly.
Or sustainability efforts, optimizing energy use in massive data centers and factories in real time to drastically cut carbon footprints.
It provides 24/7 productivity and removes human error in incredibly complex systems.
And there is always a huge but here.
Always.
Removing the human introduces entirely new types of risks. The source is very clear that with this immense power comes a totally unique set of challenges that we have to engineer our way out of.
Yes.
And the big one they mention over and over is bias.
It is the classic garbage in, garbage out problem.
Explain that.
Well, if you train a corporate hiring algorithm on, let's say, 10 years of a company's past resumes,
Okay.
and those past resumes were mostly from men simply because of historical hiring practices at that company.
The AI looks at that and learns that pattern.
Exactly. It learns that male equals hired.
It doesn't inherently know sexism. It just knows the math.
Right. It sees a statistical correlation in the training data, and it forcefully reinforces it.
So you end up with a shiny new AI that might automatically penalize any resume containing words like women's chess club.
Exactly. That is a massive data problem.
So how do we actually fix that? The source mentions this concept of responsible AI as a governance framework.
Responsible AI is basically about building mandatory guardrails.
Okay.
It promotes rigorous transparency and fairness in the actual data selection process before the AI is even trained.
Right.
And a huge component of this framework is what the text calls explainable AI.
I really love that term. Because right now, deep learning really feels like a total black box to most of us.
It does to the engineers too sometimes.
You put the data in, you get an answer out, and nobody can fully explain the exact path the neural network took to get there.
Which is completely unacceptable in high-stakes environments. Think about a mortgage loan application or a cancer diagnosis.
Right, if an AI denies you a home loan, you absolutely have a right to know why.
Explainable AI aims to build systems that are forced to show their work, so that human auditors can understand the decision.
It's about the system being able to explicitly say, I made this decision specifically because of variable X and variable Y.
Exactly. Building trust.
And we're seeing governments finally step in to enforce this too.
Right.
Right? The source mentions the GDPR in Europe and other global regulations.
We're seeing a major push globally to ensure that while we enjoy all this wild efficiency, we aren't completely sacrificing our privacy or our ethical standards.
We're basically trying to rapidly build a legal framework for a technology that evolves way faster than laws can even be written.
That is the perpetual challenge.
Speaking of evolution, looking at the timeline provided in the back of the source material, it's actually kind of funny.
How so?
We sit here talking about agentic AI and neural networks like this is all brand new stuff that just happened since 2020.
Right.
But this has been a really slow burn for over 70 years.
It really puts the whole hype cycle into perspective. You actually have to go all the way back to 1950.
1950.
Alan Turing publishes his paper, Computing Machinery and Intelligence.
Right?
And he proposes the famous Turing test, basically asking, can a machine ever fool a human into thinking it is also human?
1950. I mean, that is before the internet. That's before the microchip was even a thing.
And then in 1956, John McCarthy actually officially coins the term artificial intelligence at a conference.
So the name itself is basically a senior citizen at this point.
It is.
So why on earth did it take so long? If we had the core idea in the 50s, why is it just exploding now?
Well, we had the theoretical math back then, but we simply didn't have the compute power.
The hardware wasn't there.
Right. And more importantly, we didn't have the data. AI needs massive data to learn.
Right, and the internet provided that data.
Exactly. But the source also highlights 1980 as a massive technical turning point.
Okay, what happened then?
The research into something called backpropagation really took off.
Backpropagation.
Yes. This is essentially the specific math that allows neural networks to actively correct their own errors during training.
So it's the mechanism of learning from mistakes.
Exactly. It is fundamental to how they learn.
And then you move up the timeline, and we start seeing the famous gaming victories.
Yeah.
1997, IBM's Deep Blue defeats Garry Kasparov at chess.
Right. Now that was what we call the brute force era.
Because the computer could just calculate millions of moves ahead of the human.
Exactly. It wasn't necessarily smart in any creative sense. It was just incredibly fast at running calculations.
Right.
But the real paradigm shift, according to the timeline, happens in 2011.
When IBM Watson wins Jeopardy. I remember watching that. But why was Jeopardy considered a bigger deal than beating a grandmaster at chess?
Because of the puns.
The puns.
Think about how Jeopardy works. It requires understanding natural language, wordplay, double meanings, complex riddles.
Oh, right. It's completely unstructured.
It's not just math anymore, it's human culture. The machine actually had to parse and understand the nuance of the clue.
That makes total sense.
Well, yeah.
And then 5 years later, 2016, we get AlphaGo.
AlphaGo beating Lisa Dahl at the ancient game of Go. That was the moment deep learning really flexed its muscles for the world to see.
Because Go isn't like chess, right?
Not at all. Go is a game of profound human intuition. There are literally more possible board configurations in a game of Go than there are atoms in the observable universe.
So you absolutely cannot brute force it.
Impossible. You cannot calculate every move.
I remember reading about a specific moment in that match. Move 37.
Yes. Move 37 is legendary. The AI made a move that absolutely no human expert would ever make.
It looked like a mistake at first, right?
It did. But it was profoundly creative. It was the exact moment we realized that the machine wasn't just rapidly calculating outcomes anymore.
It was feeling the flow of the game.
Yes, in a way we didn't fully understand yet.
And that leads us directly to 2022, the launch of ChatGPT and the absolute explosion of generative AI for the masses.
Right.
And now, looking forward, the source says we are rapidly moving toward multimodal models.
Multimodal.
Yeah.
Yes. Up until very recently, you had an AI for text or a completely separate AI for generating images.
Where they were siloed.
Multimodal means a single system processes text, sound, and high-resolution images all simultaneously.
So it creates this seamless, context-aware intelligence.
It perfectly mimics how humans actually perceive the real world. We don't just read a room. We look, we listen, and we read them all at the exact same time.
It really feels like we are graduating from just building advanced tools to building digital partners.
That is the exact synthesis the source tries to drive home at the end. AI isn't just a calculator anymore. It is deliberately designed to augment human potential.
Augment, not replace.
Exactly.
I think that's the hopeful takeaway here for you listening. The real power of this tech lies in offloading the cognitive drudgery.
The sorting, the scheduling, the massive data analysis.
So we can actually focus on the high-level reasoning and the creative strategy.
Let the agentic AI deal with the airline websites and optimize the logistics so you can actually focus on why you are taking the trip in the first place.
Let the AI scan the thousands of medical images so the doctor can sit down and focus on the human treatment plan and the patient care.
That's the vision.
But as we wrap up this deep dive today, I want to leave you with a thought, something that keeps bouncing around in my head regarding this new agentic phase we're entering.
What's the thought?
Well, it's about that autonomy we talked about earlier.
Yeah.
The source is very clear that agentic AI executes workflows completely independently.
It does.
It creates a literal layer of separation between your human intent and the final outcome in the real world.
It absolutely acts as a proxy.
So if AI is no longer just a digital tool we hold in our hand, but it's an agent that goes out into the digital world and acts on its own.
Yeah.
How does that fundamentally change our definition of responsibility?
That's heavy.
Think about it. If the digital agent makes a critical mistake, or inadvertently breaks a law, or spends $10,000 too much while executing your travel goal,
Right.
is it the machine's fault? Or is it entirely the fault of the human who just pressed start and went to sleep?
That is the multi-billion-dollar question right there. The technology has already answered the question of capability, but our society hasn't even begun to answer the question of liability.
Exactly. Just something for you to chew on the next time you casually ask a chatbot to go ahead and plan your family vacation.
You really might just be looking at the total future of human decision-making.
That's it for this deep dive into the brain of the machine. Thanks for exploring the nuts and bolts with us.